So this will tell us what is the minimum number of colors required. Okay. So that is called chromatic color problem. So chromatic color is will tell us how many number of colors required to color the graph. For example, you take this graph, student. Here we are not taking any condition. Just observe this graph, all of you. So here we have four nodes, 1, 2, 3, 4. These are the four nodes we have. Okay. Now what is that we have to do here? We are just coloring these nodes. Okay. So here we are not taking any condition. What is the condition in the previous case? The adjacent node should not have the same color. That condition we are not taking. In that case, to solve this problem, first step is we need to generate state space tree. Okay. So initially we start with the first vertex. The first vertex can take any of these colors, red, green, blue. Vertex 1 can take red color or green color or blue color. These are the three values. The vertex 1 can take any of these three values. Okay. And vertex 2. Here we have not taken any condition. Vertex 2 can also take red color, green color, blue color. It can also take any of these values. And vertex 2, if it is taking green color here, again we have three more combinations. So the vertex 1 is taking red color. Vertex 2 will take any of these three colors. If vertex 1 is taking green color, vertex 2 can take any of these three colors. Okay. Vertex 3 is taking blue color and it will be taking any of these three colors. So vertex 2 will be taking any of these three colors. Okay. So once we are getting this combination, these are the different possible options we have. So if you come to vertex 3 once it is taking red color and it will be taking any of these three colors. Okay. And green color, it will be taking any of these three colors like that. Okay, vertex 3 will also take any of these three colors. These are the possible combinations for vertex 3. And vertex 4 again, it is having these many options. Okay. So this is the state space with no condition. There are no condition. Here we have not taken any condition. In that particular case, in this particular case, if there is no condition at all, so how many nodes we require to complete this state space is 3 power n plus 1. Okay. So 3 power n plus 1. N is the number of nodes. Here we have how many nodes we have? 4 nodes. No? So 3 power n plus 1 number of nodes, and this is the time required to compute to find the solution. Okay. And what is 3 here? 3 is called chromatic number. How many colors we have taken here? There we have taken 3 colors. No? So 3 is the chromatic number. So what is the time required here is C power n plus 1. Okay. So here what is that? We have not taken any condition. What is the condition? The adjacent node should not have the same color. That is the condition. If you have not taken any condition, in that case, we are getting a state space with how many solutions? It is 3 power n plus 1. So it is also requires the same time. Time required is also same. So to solve this, to reduce this, we go for backtracking. So what is backtracking? Just see this example, student. All of you go through this. Here, what is that we are doing? First vertex is allotted with. See here, this is the graph. No, 1, 2, 3, 4 is the graph. Okay. So first vertex is allotted with the red color. Once the vertex 1 is allotted with red color, vertex 2 is adjacent to vertex 1. Mama. See here, students, vertex 2 is adjacent to vertex 1. So the vertex 2 should not take red color. See here, vertex 2 should not take red color. So because it is filled by bounding condition. What is the condition here? It should not have adjacent color. Since vertex 1 is having red color, vertex 2 should not have red color. So what is the other option we have? Vertex 2 can take green color. So vertex 2 is taking green color. So here vertex 1 is taking red color. Vertex 2 is taking green color. Now we are coming to the vertex 3. Vertex 3 is adjacent to vertex 2 now. Vertex 3 is adjacent to vertex 2. Okay. So vertex 3 can take red color because it is not adjacent to vertex 1. Okay. So it cannot take green color. Vertex 3, see here, vertex 3 should not take green color. It can take what? Red color. Okay. So if vertex 3 is taking red color, then vertex 4, come to vertex 4. Vertex 4 should not take red color because it is not satisfying the condition. So it should not take red color. So what is the other option we have? It can take green color. Okay, it can take green color. So what is the first solution, students? The first solution is vertex 1 is red color, vertex 2 is green color, vertex 3 is red color, vertex 4 is green color. This is the first solution. Next, what is the next solution? Instead of green color, we can also give blue color because we have given with three colors, red, green, blue. We have given with three colors here. Instead of green color here for vertex 4, we can also give you blue color. Okay. So that is the second solution. Okay. Now we are just going backtracking. See here, vertex 4 is taking all the three colors. Red color it cannot take, green color it can take, blue color also it can take. Okay. Then we are going for backtracking. So vertex 4 we have completed now. We are going back to vertex 3. Vertex 3 we have given already red color. It cannot be given with green color. Vertex 3 cannot be given with green color because it is not satisfying the condition. It cannot take green color. What is the other option for vertex 3? The vertex 3 can take blue color. Okay. So that is why we have third solution. See here, red color, green color, blue color, and green color. Okay. Like that, we have infinite number of solutions, students. Okay. So here we have infinite number of solutions. So if you observe this graph, okay, backtracking problem, it is just like depth for search. It is just like depth for search. We are starting from the root node and going to the leaf node. Again, we are just going for backtracking. Okay, it is just like depth for search. So once we get solution, two solutions till vertex 4, we are going back to vertex 3. Once we are just checking for all the three colors of vertex 3, again we are going to vertex 2 and give the other colors, other color options. What are the other color options we have to find out the solution? Okay. So this is about graph coloring problem. Is it clear, students? May I know how many of you are listening? Please raise your hands. Nobody are listening. Only one student. Is it clear, students? Any doubts? Here we have a vertex. Okay. We should see, we have a graph. So whenever we are allotting colors to the graph, we should not give the same color to the adjacent vertex. We should not give the same color to the adjacent vertex. Okay. That is the graph coloring problem. Okay. Now we'll see the solution program, student. Graph coloring problem. Okay, so what is the graph coloring problem we have discussed? The graph coloring problem, all of you see this. The graph coloring is the procedure of assigning colors to each vertex of graph such that no adjacent vertex get the same color. What is graph coloring problem? The adjacent vertex should not have the same color. Okay. And what is the object here? The object is to minimize the number of colors while coloring the graph. Whenever we are just allotting colors to the graph, we should use minimum number of colors. Okay. The smallest number of colors required to color a graph is called chromatic number of that graph. So what is the smallest number? If you take any graph, the minimum, what is the minimum number of colors required to color the graph is called chromatic color. Okay. So So graph coloring problem is a NP complete problem here. Okay. So what is the methods to color the graph here is the first step is arrange the vertex in a some order. So this is the graph we are taking, students. We are arranging the vertex in some order. So A, B, C, D in some order we have the vertex. Choose the first vertex and color it with the first color. So first we have to choose one vertex and color the first vertex with the first color. Okay. Next, choose the next vertex and color with the lowest number color that has not been colored on any vertex adjacent to it. Okay. Whenever you are coloring next vertex, you have to select a color which is not colored to any of its adjacents. Okay. So that color we have to select to color that particular vertex. If all vertexes are colored with the same color, assign a new color to it. Okay. Whenever, say for example, you are taking vertex B. Okay. So it is adjacent to the vertex A and C. Okay. So if these colors are already new colors, some colors are allotted. So then we have to assign new color to vertex B. Okay. So if all adjacent vertex are colored with the same color, so here you see AC are colored with the same color. So that is why B is allotted with the new color. So this procedure will be repeated. So what is that we have to do? First we have to arrange the vertices in some order, and first we'll be assigning first color to the first vertex, and choose the next vertex such that the color which is not colored to its adjacent will be allotted to the next vertex. Okay. So this procedure will be repeated till we have colored all the vertices. Okay, this is the graph coloring problem, students. Okay, here what is that we have taken? Vertex A is the Telangana, B is the Karnataka, C is Tamil Nadu, D is Kerala. Kerala. Okay, four vertices we have taken. Okay, now we have to give different colors for each vertex. Okay. Now, what are the application of graph coloring? So, usually for register allocation, graph coloring will be used, and for map coloring also graph coloring will be used. Okay, but bipartite graph checking also it is used, and mobile radio frequency assignment. For this also graph coloring problem will be used, and making timetable. So whenever we are making timetable, we have to assign different colors. So for that also we are using graph coloring. Okay, these are the different applications of graph coloring. Okay. Now we'll see the program, students. Okay. All of you see this program. Here first the colors are given. What are the colors taken? Red, blue, green, yellow, black. These are the different colors are given. So initially we'll give only the three colors. Okay. So because our graph is having only 4 nodes, 3 colors are sufficient to represent 4 nodes. If you give more colors also, it will take only 3 colors. Okay. And what are the states? Telangana, Karnataka, Tamil Nadu, Kerala. These are the 4 states. If you see this graph, what are the states we have? Telangana, Karnataka, Tamil Nadu, Kerala. These are the 4 states we have. Okay. Okay. And what are the neighbors of Telangana? Neighbors of Telangana, Evaramma? First node is Telangana. No, neighbors of Telangana is Karnataka. Okay, only the Karnataka, and D is Kerala. So we just write the neighbors of Telangana. So Telangana neighbors are Karnataka and Tamil Nadu. So we just take the graph. From the graph, we are writing what are the neighbors of Telangana. Telangana neighbors are Karnataka and Tamil Nadu. And neighbors of Karnataka are Telangana, Tamil Nadu, Kerala. These are the neighbors. Like that, for every node, we have to represent its neighbors. Okay. Neighbors of Tamil Nadu is Telangana, Karnataka, Kerala. And neighbors of Kerala is Karnataka and Tamil Nadu. Okay, like that. This graph, the same graph we are representing here, and its neighbors we are representing here. Initially colors of states will be, no colors will be allotted. Okay, now come to this program, students. Here the main program for states in state. For states in state, colors of state is equal to get color for state. Okay, so what is that? For first we are assigning some color to the state. Okay, so get color for state. Okay, for colors in colors, if promising color, which color will be allotted to the state? So if the state color and state and color, we are calling this function, student. This function, in this function we will be checking whether the neighboring state is having the same color of the state. State is the present node, and neighboring state is the neighboring of this state. Okay, if the neighboring color is equal to present state color, then it will be returning false. If the neighboring color is different from the present color, then it will be returning true. Means that that color will be allotted to the neighbor. Okay, so like that we'll be just allotting different colors to the states. Okay, so you just run this program. If you run this program, here we are using three functions, students. This is the main function. In that, first we are just allotting colors to the state. Okay, the colors will be taken from colors, and it will be checking whether the neighboring state is having the same color or not. If the neighboring color is having state is having same color, it will return false. Otherwise, it will return true. Okay, so the Telangana is having red color, Karnataka is having blue color, Tamil Nadu is red, Kerala green. Okay, like this we are allotting different colors to the each state. See here, the neighboring states does not have the same color. Okay, if you give more colors also, it will take minimum colors required. Okay, so it does not take more colors, it will take minimum colors required to color the graph. Okay, so you just give more colors here and check. If you give more colors and give check also. So for example, if I give black, yellow. Okay, so if you just run this program again, you can see that it will take only the three colors. So the minimum colors required to color the graph will be only three in this case. Okay. Is it clear, students? Any doubts here? Hello, students, please respond. Is it clear? Any doubts here now? Do you want me to explain anything? Students, you please respond.
No, ma'am, but after completing classes, once share the program, ma'am.
Yes, ma'am, I will share. Last week program also I did not share. I will definitely share. Okay, all of you run this program in Google Colab now. Let me note down the attendance. And I'll explain this program once again, students. That's fine. Please listen to the classes. Okay. This subject, students, myself, I'm teaching, I'm feeling difficult. Okay, if you people don't read properly, it is going to be very difficult. So all of you concentrate on this subject. Okay. let me explain this. Still we have 15 minutes time. So I'll explain this once again, students.